Hello students. So we have seen uh, flow through pipe, and in that we discussed about major losses, and then after we discussed about minor losses. So today this will be the third lecture for pipe flow or flow through pipe, and this will be the last. So in this lecture we will discuss some of the definition and some of the theory that we will discuss. So which are the content that we will first discuss. So now flow through pipe, here you can see which are the content remaining. We already discussed these two. Now hydraulic gradient and total energy line, pipe in series and parallel, equivalent pipe, and water hammer in pipe. So these are the theory pending. Now we will start with this hydraulic gradient and total energy line. Now we will not solve any numerical. Here you will have to just remember that what is hydraulic gradient and total energy line. Now here we know that whenever liquid is flowing inside pipeline, જ્યારે લિક્વિડ ફ્લો થાય બરાબર ને, તો એની પાસે ત્રણ એનર્જી હોય. જ્યારે ફ્લો થતું હોય તો એની પાસે જ્યારે ફ્લો થાય ત્યારે પ્રેશર એનર્જી હોય. આપણને ખબર છે એકોર્ડિંગ ટુ બર્નોલી ઇક્વેશન પ્રમાણે શું કઈ ત્રણ એનર્જી હશે? ઇટ વિલ હેવ પ્રેશર એનર્જી, ઇટ વિલ હેવ કાઇનેટિક એનર્જી, and it will have potential energy. So three energy it will have: pressure, kinetic, and potential, or due to height difference. So hydraulic gradient line means it is a line indicating only summation of only two: pressure head and datum head. Pressure head means P by rho g. This is basically P by rho g plus its potential energy. So here this head, pressure head plus datum head. So if you will add these two, so that will be known as hydraulic gradient line. And if you will add all of three, P by rho g plus V square by 2g plus Z, so that will be known as total energy line. Clear? So this concept is easy to understand. In diagram also you can see one of the example here. One example is solved. So in example you can see that whenever here we have one tank, and from tank one pipeline here we connected, and from tank water will flow inside this pipeline. So whenever it before it enters here, it will have Z means it has height. Clear? And this will be our atmospheric pressure. So total, whenever it enter into pipeline, so what will be total energy? Here this will be the total energy. Clear? Now if you will subtract kinetic head from that, so you will get hydraulic gradient line. So always hydraulic gradient line will be below. In this condition, hydraulic gradient line will be below this total energy line. Clear? So total means summation of all three, and hydraulic means only pressure and datum head or Z. So this is difference between TEL and hydraulic gradient line. Now then after which is the topic remaining? Then after pressure in series and parallel, pipe in series and parallel. So for series and parallel we will have to 508. We will have to go to a next page. So if you also want to solve numerical, so you just this much theory concept you will have to remember. Then after you can solve numericals. Now here we have flow in pipe in series. So whenever flow take place inside pipeline. So suppose these are the pipeline in series. So we know that we are adding resistance. We know in our electrical circuit we are adding resistance in series circuit. So here also what you will have to do, you will have to, if any loss is there in any pipeline, so that loss you will have to add. If you want to find out total loss, if you want to find out total loss, and suppose you have three pipeline, so you will have to add like this: head loss in first pipeline, head loss in second, plus head loss in third. So in first also two type will be there, major and minor. Major will be because of friction and minor will be because of some contraction, expansion. So here also major and minor both will be there. So if you want to find out head loss in pipeline, what you will have to do, you will have to add all head loss in all the pipeline, and that also major and minor both. So suppose here we have pipeline, here you can see that we are transferring water from this tank A to tank B, and we have connected these pipeline. Now here three pipelines are there, three pipes are there. First pipe has a diameter D1, second has a diameter D2, and third has a diameter D3. So here suppose we want to find out total head loss. So here initially entry loss, friction loss. So this is for pipeline 1, this is for 1. Now this is our minor and this is our major. Then after in second pipeline, this is because of here we have also size difference or contraction. So this is our minor losses, and here this is major losses. So these two are for second pipe, and then after for third, here these are the different loss for third pipe. But if you want to find out total head loss, so what you will have to do, you will have to add head loss from all, but in parallel. Situation will be different. So suppose flow is taking place in parallel, સપોઝ ફ્લો પેરેલમાં થાય છે તો શું થશે, તો હેડ લોસ બંનેમાં સરખા હશે. બંને પાઇપલાઇનમાં, સપોઝ આ પાઇપલાઇન એ છે અને આ પાઇપલાઇન બી છે, તો બંનેના હેડ લોસ સરખા હશે ઇરરિસ્પેક્ટિવ ઓફ ઇટ્સ ડાયામીટર. આનો ડાયામીટર ગમે તેટલો હોય પણ હેડ લોસ બંનેના સરખા થશે. જ્યારે આમાં એવું નહીં થાય, જ્યારે પાઇપલાઇન સિરીઝમાં હશે ત્યારે એવું નહીં થાય. ત્યારે શું થશે, હેડ લોસ બંનેના અલગ અલગ હશે અને ટોટલ ફાઇન્ડ આઉટ કરવા માટે તમારે બધાને સમેશન કરવું પડશે. ક્લિયર? સો લેટ અસ લુક ટુવર્ડ્સ ફ્લો ઇન પેરેલલ પાઇપ. Flow in parallel pipe. So here you can see that flow is taking place in parallel pipe. So here we have one pipe, here one and second pipe. Now here you can see discharge will be total discharge will be discharge 1 plus discharge 2. But here you can see that head loss for first pipeline is equal to head loss for second pipeline. So this is you can apply for flow in parallel pipeline. Now which topic remaining? Equivalent pipe, equivalent diameter. Now suppose you have a pipeline with different diameter and you want to convert this pipeline into single diameter. Suppose here you have one pipeline in which suppose this is bigger diameter, then after smaller diameter, then after another diameter pipeline, length are also different, then after you have another diameter. So here you can see the diameters are different, D1, here D2, D3 and D4. But suppose you want to convert these all pipeline in a single diameter, so let us tell it as a D. So how we can do that? So for that this concept you will have to apply, that head loss you will have to sum all the head loss from all section. Then after final formula, we are interested in final formula. So what will be our final formula? Here you can see that this will be the final formula. This is our final formula. So by this formula we can find out D. Here you can see L1 means length of pipe 1, D1 means diameter of pipe 1, L2 means length of pipe 2, diameter of pipe 2, length of pipe 3, diameter of pipe 3. So here L will be summation of L1 plus L2 plus L3, but you can find out diameter here. You can find out that what should be the diameter of equivalent pipe. So I hope you understood this. So then after only one topic remaining, water hammer. Now already I told you water hammer in which video? In hydraulic ram. I explained you about water hammer. So here now water hammer means, as I told you, suppose flow is taking place in pipeline. Suppose flow is taking place in one pipeline, and here you have kept one valve. Now if we have valve, if you will close this valve suddenly, what will happen? Pressure at the back side will increase. If you will close this valve suddenly, so which is our back side? So this will be the back side. So here pressure will increase suddenly, so this effect will be known as water hammer. Clear? So I hope you have understood. So here we are stopping this video. Thank you for listening me.